G'day, this is Mr. Thompson again. I thought I would follow up my last video with some more examples. My last video on electron configuration contained a bit of explanation. It was quite long, didn't have too many examples. So let's do a couple of examples of both full electron configuration and abbreviated electron configuration. All right, I'm going to use this periodic table which has got a lot of blanks in it. The reason I'm doing that is because I'm going to scribble a lot of things on my periodic table, and I want you to be able to see my scribbles very easily. You will use a full periodic table with all the squares filled in, but if I did that, as I said, you wouldn't be able to see my scribble. So I'll just put the important information on here, but you will do this with a full periodic table. All right, I mentioned in my last video, the only thing you really need to remember is the letters S, P, D, and F in that order. So maybe some pigs don't fly, or I don't know, some other way. Just somehow remember S, P, D, F in that order. Okay, all right, before I start, I'm going to mark up my periodic table with some useful information that will help me. So the first thing you may notice already is that, not red, I'll go back with my blue for a little while. Normally helium lives here, yeah, but I've taken helium out of there, and helium, when we do electron configurations, we consider helium as being over here in what we're about to call the S block. All right, now I'm going to label the blocks on my periodic table. So starting from the top of the periodic table and working our way down, the first block, the highest block, the one that sticks out the top the highest, is our S block. So I'll write S there. The next one, the next highest one, is our P block. So I'll put P there. That's our P block there. That whole region there is our P block. This region here, the next one down, is our D block. And as we continue down the periodic table, we've got our lanthanides and actinides, which are our F block. Now, of course, you know that they actually belong in here, don't they? The lanthanides and actinides actually belong up in there. But if we put them in there, that makes a very wide table, and it's too wide to fit on a page, so we put them down there. All right, now I'm going to number some, I'm going to put some numbers down the side of each block. The S orbitals in an electron configuration, well, they exist in all shells. So the first shell, second shell, third shell, they all have, down to the seventh shell, they all have S orbitals. So I'm going to number 1, 2, 3, 4, 5, 6, 7. I'm going to number the rows in the S block of the periodic table. Okay, the P subshell, or the P orbitals, they don't appear in the first shell. They only appear in the second shell onwards. So I'm going to label the P block 2, 3, 4, 5, 6, 7. The D orbitals, well, they only appear from the third shell onwards. So I'm going to label them 3, 4, 5, and 6. And the F subshell, the F orbitals, they only appear from the fourth subshell, or from the fourth shell onwards. So I'm going to label them 4 and 5. Okay, so that's pretty easy. S starts with 1, P starts with 2, D starts at 3, and F starts at 4. Quite easy to remember. All right, so let's walk the periodic table and let's work out some electron configuration. So I thought I might do sulfur first. So here's sulfur here on the periodic table, and we're going to start, as we always do when we do electron configurations, we're going to start over here with hydrogen, and I'm going to do 1s2. Okay, what does that mean? The 1 means I'm starting at those electrons are going into shell 1. The S block, what that means is those first two electrons are going into the S orbitals, or the S subshell of the first shell, and there are two of them. 1, 2. And we know there are 2 because that S block is 2 elements wide. Okay, now I walk across my periodic table, and as I come across my periodic table, I find that there are no other elements in that first period. All these ones are in the second period. So get to the end of my first period, I come to my second period, I can start again. Now I hit that 2 there, means I'm now in my second shell. And I'm in my S subshell again because I'm on my S block, and 1, 2 electrons. All right, I walk across my periodic table. This time I do hit my P block. Okay, 2 there tells me that I'm still in my second shell, and I'm in my P block. How many electrons? Well, let's count. 1, 2, 3, 4, 5, 6. 6 electrons are added as we go across that P block, so that means 6 electrons are added into the P subshell. So I'll put a 6 there. Okay, now I'll come down to my next row. I've got 3 S2, third shell, S orbitals, S subshell, and 1, 2 electrons get added. Now I come across to 3 P, 1, 2, 3, 4. Okay, I only need 4. I don't need 6 because I'm not, once I get to sulfur, that is my electron configuration for sulfur. That's all I need. Okay, so there it is. There's my electron configuration for sulfur. Sulfur. And I'm an Australian, so I spell it that way. All right, let's look at the abbreviated electron configuration for sulfur. So what I do with my abbreviated electron configurations is I start with the noble gas in the period above the element that I want the configuration for. So I'm going to start with neon because that is the noble gas that is above sulfur. So I'm going to put neon in square brackets, Ne. Okay, and what that means, neon in square brackets, it means whatever the electron configuration for neon is, we're going to start with that, and then we're going to add some more electrons. So that's everything up to 2p6. Yep, that's the electron configuration for neon. So they're the core electrons, and the ones we're about to add, those ones, they're the valence electrons. And of course in chemistry, the valence electrons are the interesting ones. So in an abbreviated electron configuration, we only write the valence electrons. So start with neon. Okay, we come down to here, we've got 3 S2, and across the table here, 3 P, 1, 2, 3, 4. And of course, those last valence electrons are the same as the last electrons on the full electron configuration. So both of those are sulfur. It's just that one is the full configuration and one is the abbreviated configuration. All right, let's do another one. Let's do lead. It's going to be a bit more interesting because it's so far deep down in the table, and you will see that the electron configuration for lead is going to be quite a long configuration, and you'll see how useful the abbreviated configuration is. All right, it's very deep. It's going to take a while. I'm going to move quickly. So we're going to start with our first shell. 1. We're in our S subshell, and we have 1, 2 electrons. 1 S2. That's all we've got in the first period. We come down to the second period. 2 S2. 1, 2. Come across to 2 P6. 2p6, 6 electrons. 1, 2, 3, 4, 5, 6. Then we come across to our next period, and we're in our third shell, S subshell there, 2 electrons. We're still above that D block, so with our next block that we encounter again is our P block, and it's going to be 3p. There's 6 of them, so we keep going. We come down to 4 S2. Now we hit our D block. And our D block, we've got a 3 there. That means when I fill my D block, I'm actually backfilling into the third shell, not the fourth shell. Okay, so 3D, it's my D orbitals, my D block. And how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 electrons fit into the D orbitals, or the D subshell of the third shell. Okay. Moving along, back into the fourth shell, even though it's the same period, the 4p, 1, 2, 3, 4, 5, 6, 4p6. Okay, come down to here, we've got 5s2, 4d, let's see, 10 again, and 5p6, P6. Oh, we're getting there. 6S2. Now this is where it gets interesting. Get to 6S2. Now I can't just go across to my D block because, of course, jammed in there are my lanthanides and actinides. So I need to, I'm going to go across that period. I really need to come across here, and then continue across there like that, because that actually belongs up in there. All right, so what do I do? 6S2. So now I'm continue across. Now I'm in my fourth shell because I've got a 4 there. 4F. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now I come back up to here, going across the table still. Remember, they belong in there. And I've got 5D10. Okay, and now I've got 6. I'm just going to fit 6P12. I've only got 2, and that is my full electron configuration there. That's my full electron configuration across there. Hopefully that fits on the camera for lead. Now, what about the abbreviated configuration? That's a huge configuration to write, and as I mentioned before, the only electrons we're really interested in are those valence electrons, the last electrons. So what I'm going to do, lead, I'm going to look at the period above lead, and the noble gas above lead is xenon. So I'm going to start by putting xenon in square brackets. Xenon. So what those square brackets with xenon, what they indicate that everything up to the end of 5p6 is in those square brackets. Okay, so it means that's what that represents. Then from xenon, now I just walk the table. After xenon, I've got my 6s2, coming down to my lanthanides and actinides block, my F block, and I've got 4F14, and back up here to 5D10 and 6P2, 1, 2, and we've arrived at lead. So both of these, that's a 2 there, both of these are electron configurations for lead, except that's the full electron configuration, and that's the abbreviated electron configuration. And again, these ones here, they're our valence electrons. They're the interesting ones. They're the ones that take part in chemical reactions. All right, I hope that's helped.